the region common to both r equal 3 the sine of theta, 0, 1, 2, 3. We know that's a graph that looks like this. And how about r equal 2 1 above and 1 below? Sine is start at the origin, but it's upside down. So I know this is a graph wrapped around the negative x-axis, negative the y-axis, I'm sorry, 2 pi over 2, and 3 pi over 2. At 0, I am at 2, 0, 1, 2. It decreases. By the time I reach pi over 2, I am at 1. Pi over 2, 1. Then it increases. By the time I reach pi, I am at 1. I am at 2, I'm sorry, 1, 2. And then it keeps on increasing. By the time I reach 3 pi over 2, I am at 3, 3 pi over 2, 1, 2, 3, 1, 2, 3. And I know from symmetry it's going to go back, and there it is, and that is this part. Okay, well now what do they want? They want to find the region common to both. That part. Now, these are symmetric. I'm going to assume they're not symmetric, but again, the right half and the left half are the same, so I'm going to assume that those two do not look alike. I'm going to say area equal, because this is 3 and that happened to be 3. If this was a 4, then they wouldn't be symmetric. You will have to do what I do. I'm going to take the integral. If I start at 0, I wanted to go to the purple. There's the purple. I needed to run to 3 sine of theta squared d theta. Now let's see. It's going to run to the purple, which is fine, but I needed to run to the purple until that angle right there. And once you're down from that angle, after that, I needed to run to the orange all the way to pi over 2, 2 minus the sine of theta squared d theta. Now by symmetry, I'm going to say this right half and this left half look alike and multiply that by 2. But I need to know where that angle is. And how do I do that? I set them equal. Where does 3 sine of theta equal 2 minus the sine of theta? That is when 4 sine of theta equal 2, or sine of theta equals 2/4, which is 1/2. That means my angle happens to be a pi over 6. So where they cross, where they meet, is at pi over 6. There. Now, because of symmetry, I don't have to go on and figure out the rest. And that's the least amount of work we can do. All right. Then we get to this problem. Okay. Again, these are symmetric. I'm looking at r equal 3, the cosine of theta. I know what that is. That's a graph that looks like this. And 3, the sine of theta, I know what that is. That's a graph that looks like this. What do they want? Common to both regions. Again, they're talking about literally this portion. Again, this is symmetric. I'm going to assume it's not symmetric. It would not be symmetric if this was like a 4. So the way it's going to work, I really don't need the graph for this one. I'm talking about the grid. So in this case, no need for that. I could say area equal the integral. Let's see how this works. From 0, I want to run to the, and let me show you the function. I want to run to the orange, right? 0 to the orange. That's 1/2. The orange function, what's that function? Oh, I'm using red. I shouldn't use red. A few students have a hard time seeing this color. Okay, but again, the same issue happens. That's until you reach. Now, you could multiply that by 2 and you're done because they're symmetric, but assume they're not symmetric. Then what you want to do, you want to figure out what this angle is. Again, you multiply that by 2, you're done. Assuming it's not symmetric, if they gave you this as a 4 or this as a 2, then you're going to run from that angle all the way to pi over 2, and you really want to run to the green function. And the green function is 3 the cosine of theta squared d theta. Now you can't swap those, meaning if you did the green first, if you were to put the green in here, that's going to find this area, and that's not what we want. So just be careful with that. It's not as simple as, oops, I just messed up. Now how am I going to figure out where they're equal? I'm going to take 3 cosine of theta and set it equal to 3 sine of theta. If I divide by cosine both sides, I'll get 1 equal the 3 sine over cosine of tan of theta. And I know that happens exactly at pi over 4. Or simply, where does sine and cosine equal? Sine and cosine are equal at pi over 4. Again, this goes back to your trig. And you proceed with each one of those and go from there. The next graph, r equal to, that's the shift, 1 unit above and 1 unit below. So r equal, did we do that already? 2 plus the sine, I don't know, that looks familiar. Oh, we did that in the last homework. We graphed those in the last homework. Okay, sorry about that. All right, so if I am at r equal 2, and I move 1 unit up, that's 3 and 1. I graph and a sine wave. There it is. 2 pi over 2, 3 pi over 2. So at 0, we are at 2. Increases. By the time we reach pi over 2, we are at 3 pi over 2, 1, 2, 3. Then it decreases. By the time we reach pi, we are at 2 again. It keeps on decreasing. By the time we reach 3 pi over 2, we are at 1, and 3 pi over 2, 1. And then it increases. By the time it reaches 2 pi, it closed in. Okay, now if you pay attention, this is area equal the integral. If I enclose in that f of theta 2 plus sine of theta, I'm going to start from the origin and run toward the graph, and I see how it increases. Notice what they want. They only want it above the x-axis. I could run it from 0 to pi over 2, multiply it by 2. I could run it all the way to pi. That will work. And that's all there is to it. Okay, cosine. We did cosine, didn't we? Yeah, I think that happened yesterday too, and I switched the cosine. Let's switch this to a sine, even though this is, so it's the same as the previous problem. We did a cosine already, nothing's going to change. Let's make that r equal 4 the sine of 3 theta. So just so that you have something different between numbers 192. So the only difference will be, if I was to keep it, you'll put a 4 right there. Next to the cosine, you'll put a 4. But if we make it a sine, then we've seen both. I'm suspecting that your homework has a sine, but it's okay. It doesn't really matter. It's a good practice. So I'm going to go up 4, 1, 2, 3, 4, and down 4. A graph of a sine wave starts at the center, runs up, and that is 2 pi over 3. This is half of it. Pi over 3. This is half of pi over 3. Again, when we say half, if you're dealing with fractions, you multiply by half here and divide. 1 pi over 6, 2 pi over 6, 3 pi over 6. So this is what we know. We need to go to 4. Let's get rid of that one. Actually, that's right. Okay, at 0, I am at 0 in this case. This increases. By the time I reach pi over 6, I am at 4. There is pi over 6, and there's 1, 2, 3, 4. So if it took it 30 degrees to get the bottom half, it's going to take it 30 degrees to get the upper half. Now we have a 3-leaved graph. So they are 2 pi over 3 apart. Well, since this is over 6, to make that over 6, multiply by 2. They're 4 pi over 6 apart. So that's 1 pi over 6. You're going to go 4 more. 1, 2, 3, 4. 1, 2, 3, 4. It's going to take, remember, 30 degrees above and 30 degrees below to maximize, and 30 degrees above and 30 degrees below. And there it is. Now, if I start integrating from 0, if I am to substitute the 1/2 for sine of 3 theta squared d theta, by putting 0, it's going to start running right there. If I have it run all the way to pi over 6, pretty much, if they want one pedal, I just multiply by 2. If they want all of them, I multiply that by 4. They only want one pedal. Of course, I could integrate from 0 and run it all the way to pi over 3. That will work as well instead of pi over 6. This way I don't have to multiply it by 2. Whatever makes you happy. Just don't overdo it and mess up the problem. Looking at this problem, enclosed by r equal 1. I'm going to move a unit above and a unit below. Sine wave starts at origin. So I just need 2 of those. And those are really not needed either. I don't need those. It's not. And let's take that one and there. Make it 2. Okay. Well, let's see how this works. At 0, I am at 1. 0, 1. This increases. Remember, this is 2 pi, pi, pi over 2, 3 pi over 2. By the time I reach pi over 2, I am at 2. decreases. By the time I reach pi, I am at 1, pi 1. Keeps on decreasing. By the time I reach 3 pi over 2, I am at 0, and then increases back, and there it is. They want me to find the area enclosed, area equal the integral 1/2 1 plus the sine of theta squared d theta. In this case, I could run this from 0 all the way to 2 pi, and it's safe to do that because I could tell it took 2 pi radians to complete the full graph. Okay, we have 3 more to go. All right, let's do this one. We would like to sketch a graph of this. Let's see how that plays. R equal 2. We're going to move 4 units above, 4 units below. So, if I am at R equal 2, and I moved 4 units above, that's R equal 6. And if I am at R equal 2 and moved 4 units below, I am at R equal -2. Now, cosine starts on the amplitude. Oops, no, mistake. Not the last one. It's right. 1, 2, right there. So you ignore the original black line because you're going only by the shift. There you go. There and there. Very good. This is 2 pi. This is pi. This is pi over 2. And this is 3 pi over 2. Now here we gotta be careful because we really want to get that part labeled correctly. So let's see. And it's 6. Okay, I gotta what do you call that? Scale it. At 0, I am at 6. At 0, I am at 1, 2, 3, 4, 5, 6. Decreases. By the time I reach pi over 2, I am at 2. Pi over 2, so these are 2, 4, 6. I am at 1, 2. So from 6, it decreases. Now comes the crucial part. It's going to keep on decreasing, but it's going to hit 0 before I reach pi. It's going to come down. Before I reach pi, it's going to hit 0. Can I figure out where that is? Can I figure out where does 2 plus 4 the cosine of theta equals 0? Well, I know that's going to happen when cosine of theta equals -1/2. I have a reference angle of pi over 3, and cosine is positive. So it is 2 pi over 3 and 4 pi over 3. So I do know that by the time you reach 2 pi over 3, it zeroes out. And then between 2 pi over 3 and pi, it's negative. Between 2 pi over 3, if r is positive, you're in this quadrant. If r is negative, you're right there. By the time you reach 2 pi over 3, you are at -2. By the time you reach pi, you're at -2. Pi, -1, -2. So it's going to run from here, and there it is. Then what happens after that? After that, it comes back. between pi and 4 pi over 3, between pi and 4 pi over 3. If r is positive, you're right there. If r is negative, you are right there. By the time you reach 4 pi over 3, it zeroes out again. By the time you reach 4 pi over 3, it zeroes out again. There you go. And then between 4 pi over 3 and 3 pi over 2 is positive. By the time you reach 3 pi over 2, you are at 2. 3 pi over 2, 1, 2. Between 4 pi over 3 and 3 pi over 2, it's positive. And then, what color here? It keeps on increasing. By the time we reach 2 pi, you are at 6. What do they want us to find? Find the area enclosed by this and outside of the inner loop. Okay, what does that mean? They want this area. Well, let's see how this plays. There is no shortcut to this one. Area equal, oops, integral 2 plus cosine 2 plus 4 cosine of theta squared d theta. This is what this is going to do. If I start at 0, this is what it's going to do. Do you see the issue? It runs from the pole all the way to the function. Now, it's going to stop at 2 pi over 3, right? And the issue is it's including the loop. If I multiply it by 2, that will get me the entire enclosed region. But if I take out 2 pi over 3 to pi, from 2 pi over 3, 2 pi over 3 to pi, if I subtract this part out of what? The same function, then guess what? That'll give me exactly what I want. So without subtracting this off, you're going to take the whole area. You want to take off the area of this loop. The only way to do it is to subtract. Where does the loop begin? Now I stopped at 2 because I'm multiplying that by 2. I stopped at pi. I could have said 2 pi over 3 to 4 pi over 3, but then to have to adjust this one and add another. So the easiest way out is just using symmetry. That saves you a lot of work. How about those two graphs? R equal 3 minus the sine of 2 theta. So R is always, let me see, let's go 3 2 units above and 2 units below. So since R is always positive, I really don't need those. Oh, I do. Never mind. Okay. I'm going to start with a sine cosine wave. Oh, my scale is way off. That's okay. This is 2 pi. Pi over 2 and 3 pi over 2. So at 0 you are at 3, 1, 2, 3. We know what this is, one of those. Decreases. By the time you reach pi over 2 you are at 1. Then increases. By the time you reach pi you are at 3. And then keeps on increasing. By the time you reach 3 pi over 2 you are at 5. Oh, I didn't pay attention to that. 1, 2, 3, 4. Okay, let's see. That's fine. That's okay. And it goes back. And this one is going to go the other way around. The same idea though, at 0. Okay, there's the mistake. Oh, at 0, I am going to be at -3. And it's going to hit 1, then increase 3, and then go up. And it's identical to the bottom one, but at the top. Now, I could set them equal to each other and say, look, where does... Here they want the area that is interior, common to both. So they're talking about this area. Again, we could use symmetry. Well, let's see how this is going to play. I could set them equal to each other, but the graph gave it away. So I would use symmetry again. Again, the graph gave it away. If I integrate 0, take 1/2. Now, it does appear that if I run from 0 to the orange, that should do the trick. Multiply that by 2 because of the symmetry. If it wasn't symmetric, I would have added another integral and I would have run it to the purple, and that would have worked. Next graph, r equal 1 plus, I just need 2 of those. Okay, we can do that. Let me get rid of that one and that one. All right, r equal 1 plus the cosine of theta. Well, at 0 you are at 2. Pi over 2 you are at 1, so we know this is a heart shape, and at pi you are at 0. And there it is. And r equal cosine of theta is a circle wrapped around the positive x-axis with a diameter of 1 oh. Okay. Well, there, better. Now what do they want us to find? Inside of the green, outside, so they're talking about this part. Well, let's see how this plays. I really don't need this. Area equal the integral. If I run from 0, 1/2, and remember how this works. Tip minus base. The tip is the green. The base is the orange. From 0 to pi over 2. Tip is the green. Remember not to combine those. That part plus the integral from not 0, pi over 2 to pi. And now if I look at this, I notice that this is only running to the green. And I would multiply all of this by 2, and that will do the trick.